So I will begin by introducing our presenter. Our presenter is Professor Paul Servatka. He is a professor of meteorology at College of DuPage. He is nationally known as having developed the most comprehensive community college meteorology program in the country. And that includes the Next Generation Weather Lab, which is one of the most widely used professional websites in the nation. And he is a pioneer in developing courses in storm chasing, which are open for students and the public. And I will let you take it away, Professor.
Okay, good evening, everyone. Thanks for coming here tonight. We're going to be talking about the weather, my favorite subject. It's what Mark Twain said, not Thomas, Mark Twain said, everybody talks about the weather, but nobody does anything about it. And I can admit to that. I wish I could do something about the weather, but I'm enjoying talking about it. So tonight I'm going to be talking about a little bit of our program, what we have here. As you heard in the introduction, we do have the most comprehensive community college program in the nation. We have courses that go from the traditional intro to meteorology, a course we call severe and unusual weather, from forecasting courses, more advanced, higher science level courses. We do thunderstorm lab, we do climate, global change, and we do hazardous weather, which is very much for those who are in emergency management as well. And then we do have our site called Next Lab, which I'll show you a little bit about and talk a little bit about that. And we're pretty well known for our storm chase program. So here's some of the things we do on our website. Probably our most used aspect of the website is our satellite page. A couple of years ago, the National Aeronautics and Space Administration helped launch a new space satellite we call GOES. GOES stands for Geostationary Orbiting Environmental Satellite. And it's one of the more advanced satellites of the world. And we are probably the #1 site in displaying and visualizing these images. There's a lot we can do with it. And we're just looking here at a visible satellite imagery, but notice that we get the entire globe, at least the entire hemisphere. And we can add color to it. So it's pretty sophisticated. That if any of you remember the old black and white images that came around once an hour, this is updating every few minutes. So it's pretty amazing. So in here, we've got something, some of our graphics. This is just a list of some of the sites that use us. We have a number of government sites, United States Air Force. The Navy is one of our most common users. We've got first responders, emergency management, schools, universities. Everybody seems to be using a lot of information from here because I think we do a pretty good job at visualizing the data. In fact, as of a little bit last year, we had about 38,000 plus unique visitors every day with over 10 million hits. And we were serving about 885 gigs of data. Just to give you some idea, when we started the program, I would call into our site for information on a modem that was around 1200 baud. So that would take several years to get just 885 gigs of data that we serve up daily. So it's a pretty impressive website. If you have a chance, go take a look at it. You're welcome to it. It's free. We have no advertising, which is what we've always tried to do, is be a service to the community and our nation. So tonight I'm going to be talking to you about weather disasters, especially those that are affecting Illinois. So this is going to be really focused to the weather events that really make the news in Illinois. But before we start that, I'm just going to kind of go through what we call billion-dollar weather and climate disasters. And just to give you some idea of the variability of these major weather events. And we're looking at pretty expensive events, but when we're starting to talk about $1 billion of damage, it's pretty amazing. So back in 2017, we had some serious drought in the Northwest and some big fires. California wildfires every year seem to be a problem, but this year it was actually California flooding in February. And this is a little ironic because I know we hear about this on the news, but it's ironic that the year of incredible amount of rainfall, we got fires. So it's not that it was dry because it's dry every summer. It's actually because it was wet, a lot of growth what came up over the early spring, and then when it dried out in the summer, as it does every year, it kindled a lot of fires. So a lot of the forest fires in California need to be managed better. I think the environment out there is, I don't think they manage the forest as well as they probably should do, because both in dry years like this year and in wet years, there's a pretty significant fire hazard. Hailstorms, severe weather outbreaks, tornadoes. This is a year we had a couple of major hurricanes. Harvey, record flooding in Houston, Hurricane Irma that hit South Florida, Hurricane Maria, which went and devastated Puerto Rico. So that was in 2017. We go to 2018, there we are in the Western fires again. Some tornado outbreaks, couple of hurricanes up the East Coast this time with Florence, a lot of flooding associated with that, some major snowstorms in winter, and then Hurricane Michael, which is a very strong storm that hit the panhandle of Florida. We jumped to 2019, a couple more hurricanes. This was just a tropical storm with flooding. Not as many tornado billion-dollar disasters in 2019, but we had a lot of flooding. So not as much fires in the Northwest, but maybe more in central California and then up in Alaska. So there's always fires, always something going on different parts of the world. Last year, we really focused on a significant amount of severe weather across the central US and a number of hurricanes. It was a fairly active year, and it's easy for a hurricane to create $1 billion worth of damage. We have so much buildup along the coasts that property is affected very easily with either flooding, damaging winds, possibly tornadoes, but mostly flooding. And then, of course, some place in the West will get fire. We had some big hailstorms. And 2021 is going to have fires again. It had some severe weather, but it was a fairly slow year in severe weather. So I want to start with weather that affects us. And the one that most people think about, if I said, what's your most hazardous weather that you're going to experience? And that's going to be tornadoes. So here's a very cool graphic, I think, of tornado climatology. Keeping in mind that the United States, which has the dominant number of tornadoes in the entire world, averages around 1,200 tornadoes in a US. And these are some of the tracks that went on for about a 60-year period. The brighter the colors, the stronger tornadoes. So when you look east of the Rocky Mountains, which is out here across this area here, we've got just a huge amount of areas with tornadoes. No state is immune to or safe from tornado damage, although we have a lot less out in Nevada in the high plains. This may be because there's not that many tornadoes, which is true, but it's also they're not going to be observed out in the middle of the desert. You can get a number of tornadoes throughout the valleys of Arizona, the Central Valley of California out here gets a lot, but certainly anywhere in the east of the Rockies, it's going to be lots. Appalachians a little bit less, probably have a lot of tornadoes, but again, whether or not they are observable. Illinois, sitting here, we have a number of tornadoes. We are in what is really Tornado Alley. So if I want to take a look at the frequency of tornadoes to really find what is Tornado Alley, I'm going to look at this upper image here. Can you see my mouse cursor, by the way? I hope you can. I've got my mouse cursor on that.
Yeah, we can see it.
So we've got from Iowa, Nebraska, southward into Texas. That's what we traditionally call Tornado Alley. But if you look across the South and across the Midwest, especially in Illinois, we have a pretty significant tornado frequency. But when we start talking about deadly tornadoes, now we're talking about areas in Texas, Oklahoma that do a lot of killing. They're very strong tornadoes. When we look at significant tornadoes, meaning the very strongest, this is where our focus shifts to the east into what we often call Dixie Alley. And these are really significant early season tornadoes, sometime maybe in March or in April. And they're going to be across the southern tier of states. So we're looking at areas of Arkansas through northern Mississippi to Alabama, just huge area of very significant tornadoes. Now, this other graph over here talks about where the fatalities occur. Well, if you take a look, the majority of fatalities come from people in mobile homes. And that's an interesting fact. But again, those significant tornadoes in the south, there is a great amount of population that are in mobile homes. Now, I'm not talking about trailer homes on wheels. We're talking about prefab housing. So a lot of times they sit up on a cement slab. They're sort of prefabricated, so the wall ends don't have a lot of structure, and they're not well attached to the foundation. And that's going to be your number one cause of failure when a tornado hits. You get some of the more well-built homes across maybe the Midwest, and we have less fatalities. Permanent houses, there's still a high amount of death in permanent houses, but vehicles are also fairly significant. Now let's take a look at how much have we been having this year. So this is the tornado season from 2021 in the solid red line over here. So that solid red line showing you a very slow start to the year, where January and February, even into early March, had very little. We had a couple of days. There was a big day sort of at the end of April into May. And then we just have not had that many tornadoes. What you are seeing with all the lines are the range of tornado counts from 2005 to the present. So the dark black line here is the average. So there we are averaging around 1,200, 1,300 tornadoes over that time period. As a result, we are way below average for this time of year. We're not at the lowest amount, which was a couple of years ago in 2013, 2018, but we are nowhere near some of the max totals when we were exceeding 2,000 tornadoes in a year back in 2011 and 2008. So pretty amazing. Notice that the number of tornadoes will grow, especially as we go into what we call the second season, which is September through maybe early November. In fact, usually somewhere in the Midwest will be a significant tornado outbreak sometime at the beginning of November. And that could be anywhere from Iowa, Illinois, maybe down into Tennessee and Kentucky. Somewhere in that area is usually one really significant tornado outbreak. So we're still going to get possible tornadoes. We go into December, can get some, but our big season, our growing path of tornado count is from March up until June. So if you look at the black line from March up into June, that's where we have the preponderance of our tornadoes. Now, when you look at fatalities nationwide, we don't average that many tornado deaths every year. It's actually pretty good from what it used to be back in the 20s and 30s when we didn't have information like satellite imagery or like radar that was able to get warnings out to people. The exception to this fairly underneath 100 people per year fatality was 2011. We had some very significant outbreaks in the Southeast. Tuscaloosa, Alabama had a significant tornado. This was also Joplin, Missouri this year. Very significant. Many people, hundreds of people died. And that's why the number jumped up to 553. But you can see since 1980, we've not even been close to that number. Ironically, because people will say, oh, it's climate change. And yet from the 553, 5 years later, we hit an all-time record low of only 10 fatalities. So tornadoes are going to be most deadly when they hit major populated areas. As we grow in population, we're going to see more deaths with the random sampling of tornadoes. The good thing is we are much better prepared for those tornadoes. Now let's focus on Illinois. Here's the Illinois tornado climatology. And this goes back all the way to 1950 over here on the left. And we're up, high variability. So we have some years that are very low. And then we have some years that are fairly high, going up to over 140 tornadoes in 2005. However, you could eye this graph and think, well, gosh, are we getting more and more tornadoes? And the answer is no. You see, what happens is with the increasing population And since the move, you know what movie came out in 1995? Anybody know that one? Should be the movie Twister. And since Twister came out, more and more people want to go tornado chasing. As a result of more people out spotting and chasing, we are now getting the reports of more and more tornadoes. So it looks like there's more tornadoes, but really we're seeing a decrease in tornadoes. In fact, over here, I'm going to look at what we call significant tornadoes. It's going to go on a scale from 0 to 5. So anything that's a 0 or 1 is a weak tornado, and it may not do a whole lot of damage. But when people are seeing it because they're chasing it, we see the numbers going up. But when we look at these significant tornadoes that are going to make the newspaper, that we have a record of, we actually see a decline in Illinois since a very strong set of decades in the 60s and 70s. So we really don't see any increase nationwide in tornadoes. And we can actually look at this next chart, the number of days in the United States for tornadoes. And since 1991, the average trend of the days is decreasing. So what we're seeing is that with some of the climate change going on, we're seeing fewer total tornadoes, and they tend to be more in clumps. Now that, from a warning perspective, is a good thing. We can let people know this is going to be a violent day, be on the lookout, and we can keep those death totals down. So in the United States, we're up at 170, 180 tornado days a year. It's pretty good. Now, the destruction of tornadoes is just phenomenal, right? We know pictures like this, just major explosions of damage, houses ripped apart. We've got trees that are completely debarked, denuded at times, metal wrapped in there, people's lives devastated within a matter of seconds. There's a picture of a school bus that's been overturned and rolled several times. Very dangerous that they even want to be a part of this. You wouldn't want any student to be in a school bus on severe weather. We need to keep the kids home while that severe weather threat is underway. I want to show you some things. These are some really cool tornado videos. I know you probably have seen a lot of tornado videos, but I think these are some of the coolest ones to show you what tornadoes do. Now, this is overlaying a backdrop of Greensburg, Kansas. This was a very significant tornado, EF5, the strongest violent tornado, wiped out 80+% of the city. And it would look something like this. So this, I'll show you this video. This is a house that is just security camera on it. And their tornado is coming. So as we kind of watch it, there's no sound on this. You'll start to see it get a little darker. And one of the things that you'll notice is that the wind is from left to right as air is flowing into the tornado, and then the winds shift direction as we start to get in circulation. And I'll just watch what happens. And there goes the house. And then it gets really dark. So what's going on here, and I think this is kind of an interesting thing to kind of point out to you, is that this is how houses fail. The first thing that happens is the roof lifts off. The roof acts like an airplane wing. The air flowing over the top creates lower pressure and pulls the roof off. Then once the roof is gone, the walls don't have much way to stay up, so the outer walls come down. And we can look at the total damage to give an idea of the strength of a tornado. If it pulls the roof off, it's going to be probably EF1 to EF2. Outer walls come down. Now we're looking at an EF2 or EF3, what we call strong tornadoes. But usually, even in those strong tornadoes, the inner walls of this house will stay up. So your bathroom might be a really good place to seek shelter if you don't have a basement. It's a little safety rule. Seek shelter at the lowest floor in the most interior rooms, and do not worry about opening windows. Just remember, a tornado, if it wants your windows open, will open the windows for you. Stay away from that glass. Seek shelter immediately. Now, this is a great tornado. This is actually a very interesting one. It's what we might call a drill bit tornado. This actually is an EF5. This is the strongest tornado in the history of Canada. And it's just an amazing thing. So I'm going to show you what this looks like here. Yeah, oops. Shoot, I wanted to go back. Don't go back for a second. I want to point out something as I find my mouse cursor. I want you to look at this area right over in here, and you will find an entire house is being lifted and lofted by this tornado. So right in there. That's the entire house. And then it shreds apart because houses aren't meant to fly. Now over here is something that's going to be fantastic. There's a minivan right over there. There's the minivan, right? Oh, did I miss it? I think I missed it. Watch over here. Minivan van full of drywall. So completely full of drywall. It's construction. The minivan, from this perspective, I don't know, what is this, 70 feet in the air? This is why so many people die in their vehicles. It's the flight's not that bad. It's the landing that will kill them. So just amazing amount of damage in very short amount of time. Okay, so here's what some of the damage would look like. This is now closer to home in Fairdale, Illinois. This was April 9th, 2015. This is a gentleman who was a senior citizen in his house. He's on the second floor and his wife is in the downstairs. So he's not with his wife and she's seeking shelter and he's just videotaping this. I will let you listen to it because he says nothing. You'll hear him breathe. Okay. So as he's breathing, let me just forward a little bit more. I don't know if can you hear that pretty well? So he's breathing and we're watching this very large, scary tornado, a couple rumbles of thunder. Notice it's not moving left to right or right to left. And that's always a bad sign. The tornado is getting larger, it's coming right towards you. So we see these multiple vortices in there as it's doing damage. For the sake of time, I'm just going to jump ahead a little bit more. Now we're starting to hear that roar. Sounds like a vacuum cleaner. Gets stronger to be more like a freight train, they always say. A little bit more panicked. Totally calm though. And that was his tornado being completely destroyed by the tornado. He somehow survived. Actually, what had happened with the camera is he was knocked out and the camera just kind of fell out and kept going. His wife did expire down in the lower floor. So he was in a much more dangerous area on the second floor and he survived. A neighbor across the street died. So that would have been one where when you have that kind of violent tornado that you may not be able to seek shelter well enough. So amazing video, in my opinion, to see what it's like inside the tornado. So let me go to the next slide here. The last slide I want to put here concerning the tornadoes is what happened this last year, which a lot of people will call the Woodridge tornado, but it's Naperville and Willow Springs tornado. This was a strong tornado, EF3, and it started out here in Naperville and just as like 75th Street, and it went fairly strongly due east, It ended up in Willow Springs, went through Burr Ridge. The most significant areas were in Woodridge, a little bit of Naperville, and then Darien. And it did have a maximum strength where you had EF3 damage. This is a house with EF3 damage. Notice most of the outer walls are gone. The inner walls are still standing. Now, there was one house in Naperville that looked worse. Maybe some of you saw it on the news. That house was completely destroyed, but we were doing a survey of that and realized that the walls were not well attached to the foundation. There was nothing keeping them in place. So once the roof came off and the walls came down, things were cleared up. So there were people hurt inside of that house. They did survive, but that house was not very well constructed. And that's the reason, the mechanism of failure for that. Big trees uprooted. Some of them were cut in half, but I've seen worse damage for trees. And then this is kind of interesting. I don't know if you were paying attention that night because it came very close to Hinsdale in the local area, is that we could actually see what we call a tornado debris signature. That the radar that we have now being used by the National Weather Service not just tells meteorologists where they suspect a tornado to be, but they actually identify it as a tornado. So at this time, there was the tornado on the ground near Naperville, and then further down here toward Romeoville, which is where the radar is, there's another smaller tornado on the ground. So it was a very active night. Illinois has actually been very active, maybe one of the most active tornado states of the year. Kind of crazy. So tornadoes come from thunderstorms. So this map here is showing you where the thunderstorm activity, thunderstorm days. So where's the area most likely to get thunderstorms? The deep south along the Gulf, and certainly the thunderstorm capital of the nation is in Florida, with over 100 days of thunderstorms throughout the Central Peninsula. And this, of course, makes sense that it's the thunderstorm capital, because what's the motto of Florida? It is the Sunshine State. So, little irony in there. Now, when we talk about fatalities, this is from lightning itself. Lightning is a very dangerous part of thunderstorms. This is from 1959 to 2017. Because Florida is our thunderstorm capital, we have also the most amount of fatalities from lightning. So all of the states in red, Colorado gets a number of big thunderstorms, a lot of lightning off the mountains, off the east. Well, you wouldn't necessarily think that, but this is where there's a lot of lightning fatalities. And then Illinois ranks fairly high in the top 20 with 104 fatalities over that period. We have networks called the National Lightning Detection Network, which will allow us to see when there's those strokes that hit the ground. They're called CGs, or cloud to ground lightning. And again, very obvious to see that Florida is your #1 lightning. That's your lightning capital. That's why you have so many thunderstorms. And then along the Gulf Coast, but certainly many, many places in the southeast and the central United States have many, many strikes of lightning per year. Now, flash floods, when we look worldwide, flash flooding is the most common type of natural disaster. 40% of all natural disasters are associated with flash flooding. And here's some examples of this. It is the leading cause of weather-related deaths in the United States, with over 200 deaths per year. So tornadoes might be averaging about 80 fatalities. Flash flooding is certainly more. And the waters rise very quickly. It's always amazing to me, but I really think people don't appreciate the power of water. It's not a swimming pool when we have a flash flood, because if you think, oh, it's just like being in the ocean or there's waves, that's not the way water works. It is extremely strong, and it's a torrent, and it pushes people, and it flips cars over, and it drowns people in their cars. Most of the people who die from flooding die in their cars because they drive into flash floods. They're costly. 10-year period, they're averaging $3.7 billion of damage to our economy every year. $3.7 billion. And 50% of them are vehicle related because people go in there. Your car does not work well in water. It floats, it gets water in the engine, and if it's moving water, it can flip it very easily. So one of the mottos from the National Weather Service that I hope all of you will remember: turn around, don't drown. Never drive into water unless you know firsthand how deep it is. That's where people are dying. More than 100 a year. It could be avoided. Now, when we have a lot of rainfall, not only do we get flash flooding, which is a very short time frame between the event and the flooding, but then as that water drains into rivers, river waters start to go higher and higher. I don't know if any of you remember from April of 2013, but this is how much rain we had across all of Illinois. Notice that the northern third of Illinois had widespread, maybe, I don't know, 6 to 10 inches of rain. And when you have that much rain, not just in an area that causes flash flooding, but you're going to get some major flooding. So we look at the hydrograph, this is called, the amount of flood waters, and we go to flood stage here, and within a couple of days later, these are all days over here. Flood stage, we went to a record flood at the Illinois River near Peoria, 28.8 feet above their banks. That was a huge flooding. Ottawa was badly flooded. Marseilles, Illinois was really badly flooded, but many, many places in northern Illinois received high amounts of river floods. And we're going to get those floods all the time. Maybe near Hinsdale, you might be looking at the Des Plaines River or Salt Creek. And the question is, well, are we getting more floods than we used to? And the answer is definitively yes. And it's not climate change. It's the way we use our ground. Everything that's paved, every house that's built is less land for the water to get into. And so if we don't let the water infiltrate into the ground, it's going to drain into a river, and that's where the flooding is going to occur. And because we urbanize, we have more flash flooding. So this is not going to be a simple fix. This is going to be around a long time. Now, other hazards associated with thunderstorms would be hail. And again, look at the numbers. On average, property is 1 billion, crop losses, $1.3 billion annually. If you look over here, Illinois, northern Illinois gets around 6 to 8 days of severe hail per year. Colorado, Nebraska, into Wyoming, that's your major areas in this region here of the highest amounts. But Illinois still has a very high amount of large hail. When we talk about sizes, we usually like to compare it to something. An inch in diameter is considered severe hail, and that would be the size of a quarter. 1 3/4 inches is a golf ball. We start getting to 2 3/4. Now we're looking at a baseball hail, and there's a baseball just to give you an idea. Updraft speeds are over 80 miles an hour coming down. These things come down at over 100 miles an hour. So you have baseball hail at 100 miles an hour, hit you in the head. That's not going to be good. I've seen hail that's much larger than this, the size of grapefruits or softballs at faster speeds, and that's going to be really bad. Now, we also have windstorms. Now this, by the way, if you can see what this picture is, this is a picture of an island up in the Great Lakes full of trees. Those are all knocked over trees. It's called a blowdown or a pack wash storm. And those are going to be very significant. If we have a really big line like we had last year, we have what's called a derecho. So just to give you an idea of that word, derecho is a Spanish word that means straight ahead. And that was to separate it from a tornado, which means to turn or to twist. So we have tornadoes, which are turning and rotating. Derechos are straight ahead. This is what we call a bow echo or a shelf cloud along the bow echo, which if you see something like this, it's going to get windy. That's just going to happen. Here's a derecho that went through, did a lot of damage from Wheaton all the way through to Elmhurst and beyond. But then it really got going. It traveled 450 miles in 6 hours with an average speed of 75 miles an hour. This line of storm started in Illinois, did damage, and then continued on. See this bow-shaped echo here? That continued all the way into the Atlantic Ocean. It hit Washington, D.C. Last year, this is an example of what the derecho did that did so much damage across Illinois, but especially in Iowa. Storm started across Nebraska and South Dakota and moved across Iowa. There were winds over 115 miles an hour. Notice it gets this like bow-like appearance, and then it straightened out a little bit as it came through Illinois, and embedded within this line of damaging winds were tornadoes. And Wheaton, Lombard, Elmhurst, Villa Park got hit with a tornado. That was pretty sizable. I think there was some more tornadoes down along into Will County into Indiana. But this is a very large line of storms that continued all the way from 8 in the morning all the way to 7 p.m. at night. So there were 11 tornadoes with this line of storms. Another famous wind event is the Missouri Duck Boat accident, which happened in July 19th of 2018. And I don't know if you recall that, but there was these boats with tourists out there, and they had a problem. They saw the line coming, and the captain goes, "Oh, we're going to be fine. We'll be back to shore before they hit." So if you're looking at this line, you're like, "Oh, see where the red is?" But that's not a good understanding. If you look at this line, it's a different radar perspective. Do you see this white line is the outflow? That's where the winds are strong. So the rain was about 15 miles away from the leading edge of the damaging winds. This they were protected from. It was the strong winds, some 70, 80 miles an hour, that flipped the boat. And I think there was some 15 fatalities with this incident. When we look at severe winds, notice that instead of the big hailstorms like we have in Colorado or Wyoming and Nebraska, the big windstorms are focused well more to the east. So Illinois, again, there we are, northern Illinois, 12, 13, 14, 15 days a year of severe thunderstorm winds. And it's outdone by areas in the Carolinas, but still a significant threat for people here in Illinois. Now, I couldn't find a good one here, but this is Kentucky, and this is a pretty nice example. The tornadoes, if you recall, are March through June. That's the big season. Our wind events tend to be more into the mid to late summer. So we have a maximum June and July, and still a high amount in April, May, and August. Once we come into September, we do get some severe thunderstorm winds across, at least this is Kentucky, but the big derecho, the big bow echo events are going to be mostly in the summer. Speaking of winds, we can just talk about Chicago being the windy city. As a lot of you probably know, it actually came from not being the windiest city. It came from the politicians who are full of hot air. But we are a fairly windy city. And ironically, when's the windiest time of the year? Spring. Summer's the least amount of wind, those hot days in August, and we don't have any breeze, and it's very muggy and uncomfortable. We go into September, we start to increase the winds, and then we go into fall and we get that windy November, and then it comes really windy as we go January through April. Not my favorite time to get wind. I like warm winds. I hate cold winds. Speaking of cold, let's talk about our winter hazard of snow. We're almost there. This is a historic record from 1884 to 2012 of how many days do we get snow with at least 1/10 of an inch of snow. And if you look closely on the left, you will see that our earliest amount was sometime around October 12th or 13th. We've had a number of measurable snows in October. There was an October 19th. This was a year in 1984. No, sorry, 1989. And I remember that well because the Cubs lost to San Francisco in the playoffs. And had it been in Chicago, the game would have been snowed out on October 19th. But instead, it was October 19th in San Francisco. also got their game canceled because of the major earthquake that happened. So October 19th was just a bad day for baseball, at least if you were in the National League that year. Now we go on and we see, whoa, here's where it really snows. So by, I'd probably say by mid-November, we have a lot of days, a lot of chances of snow events. And then we go all through snow. And then this is the depressing part. We have a lot of snow days all the way through March and a number of significant snow days all the way through April. By May, we're probably not going to get measurable snowfall, but winter is long in Chicago. Anybody know what this picture is? This is Lakeshore Drive from the Armageddon snow of 2011. We also have ice storms. Ice storms are really bad. They're the ones that are going to do all the tree limbs that come down and power lines that come down. And if you look over here, we're looking at regions where the Northeast now gets the most. We get that warm, moist air coming off of the Atlantic, and it rises upwards and it stays cold underneath it. And we get that melted water that refreezes when it comes in contact with the cold ground. Big ice storms. Illinois gets a fair share of ice storms, more across central to southern Illinois, but in Chicago, we're still looking at a sizable number of ice events. Now let's take a look at the Illinois temperature trend. And you can look at this. Blue is the trend with 1 degree Fahrenheit increase per century. And we see the average temperature, these wild swings up and down. But wow, we're definitely seeing an increase in temperature. Must be climate change. To some extent, it is. But there's some interesting data that we can figure out if we look a little bit more. Let's look at the annual precipitation. For the most part, there's your normal, the red line, and we're seeing the average going up. So what gives? Well, when we look at winter, we don't see any changes. We see the winter snowfall is about the same as it always has been since the late 1800s. We have winters of a lot, we have winters of not much. 1979, big winters in Northeast Illinois, right? 78, 79. We were outdone in parts of the area in the 50s. But those of you who say, oh, it snows all the time, well, you're wrong. Those of you who say it never snows like it was when I was a kid, well, you're wrong too. The trend is very, very flatlined. We have the same amount of snow with wide variability year after year. But when we go to the summer, we see more. Do you have any idea why we see more? We see more in the summer because we use agriculture better. On an acre of land, we are able to get much more corn and soybeans than we did, let's say, 50 years ago. Because of that corn, we put water vapor into the air. That additional amount of water vapor keeps your overnight temperatures warmer, even if your daytime temperatures are cooler, and that raises the average temperature. It also creates more thunderstorms. So most of the precipitation and the temperature changes are a result of what we're doing in our agricultural fields across most of central Illinois. It's not necessarily a result of just carbon dioxide, at least not in Illinois. Now, El Nino, you may have heard of El Nino, or La Nina, and this is really tough because we start looking, well, what's it like in the wintertime during an El Nino? And sometimes we get warmer than normal, sometimes we get colder than normal in a weak El Nino. So a lot of variability. We don't really know for sure what we get that. That's an El Nino, that's warmer waters. Currently, if we look into the Pacific, and that's where the El Nino is determined, is we look at how warm is the water. Way up to the north, we have a big bubble of warm water in the northern oceans. That's partly affected by the jet stream being ridged up here. But in the area that the El Nino takes place, which is this region in the box, we see cooler than normal waters, and we see a big cooler amount of water in the rest of the Pacific. And that means we're probably going into a La Nina this year. So what does that mean for us? Very similar to what we had last year. And I believe last year's winter was fairly cool through most of the winter, but we didn't have a lot of snow, and it was very mild start to the winter time. So if that matters, that's the forecast for this winter. All I know is that it's going to get darker earlier and it's going to get cold this winter and it's going to snow. I can promise you that. Let's look at drought, right? There it is. There's why the fires are so big out west. A lot of drought in the west. That happens a couple times every 5 years. You're going to get a couple of years of droughts. Then there'll be a big rainfall amount some year when there's maybe an El Nino come in. We are seeing this area across Illinois, Wisconsin, that's still fairly droughted. We came out of it and then we went right back into it. So it's not a big drought. It's a small aerial drought. Wisconsin's been getting some rainfall, but right here we're getting kind of dry. I don't know if you've seen your grass lately. Last week there was a couple of thunderstorms went through. My girlfriend was up north and she got rained on tons. And some storms were, I think, even producing tornadoes in Will County, but here across DuPage County, we didn't get anything. So very, very dry still in place. Okay, so now we're looking at this over the last 48 hours. There's the storms going across Wisconsin into Michigan, and Illinois is missing them all. They're all going north. We might have a chance for showers, thunderstorms tomorrow, but no guarantee. And we look, well, what's happened in the last 48 hours? Well, there's a tropical storm in the Gulf, and that's going to bring a lot of rain to the Gulf states. So that's just a little look at our weather. If you ever want to go storm chasing, come here. Go to this website. We do take people out. We haven't for the last 2 years because of COVID, but we're hoping that we're going to get out there. We have people from all over the world come storm chasing: Australia, California, Hungary, England. We've had people from Belgium. We've had people from New England, as well as Old England as well. So all over the world, they come to go storm chasing with COD. It's a self-contained class and great experience. If you're interested in chasing with us, 10-day trips start up again in April. And that's the prepared part of my presentation. I wanted to open up for questions because usually people have a lot of questions when they want to know something about the weather. But those are the things that really affect us here in Illinois. It's fun because there's always a changing weather pattern. And so we're going to be warm for a few more weeks, and then who knows what's going to happen as we go into October. Probably turn cooler by a lot. Okay, that's my thought. So we'll open it up. If people have any questions, they can talk or they can send some chat messages. What can I help you guys with?
I have a question, actually.
Yeah.
So I'm just curious, on your storm chasing classes, where do you tend to go, or does it change on different years, or do you go to specific?
Well, it changes everything. If I go way back here to this diagram, this is actually probably a pretty good diagram to look at. So we look at our areas of the United States where the tornadoes are most likely, and we want them in this region of Tornado Alley. And the reason we like to go here is even more than just the weather, is we go here because it's flat and there's open plains. We don't chase early April, March, April into early May, because if we chase down in Alabama and Mississippi, there's trees all over. It's really hard to see. They get a lot of big tornadoes, but chasing there is hills, trees, very difficult to see. We like to stay away from Oklahoma because there's too many people who chase in Oklahoma. But I like to chase in Texas. That's my favorite place, wide open out west. But then we go into Kansas. I've seen numbers of tornadoes in Kansas. And then we'll go up into the Dakotas, into Montana. Whoops, sorry. As we go into June. So April, May, I'm going to be down here across Kansas, Oklahoma, Texas. As we go into June, we're going to go up more of the Dakotas into Wyoming and Colorado. And if we go even later into June, Montana. We've even chased several years up into Canada, which is a beautiful area. Not that many chasers out there. So we'll go wherever we need to. We determine this every single day. So we're getting some questions in the chat room. Here's one. What do you do if traveling on a highway, if there's a tornado in your area? Stay in your car or get a ditch? Okay, this is a great question. So The biggest problem about being in a tornado in a car is that some people have no idea that the tornado's there, especially when there's lots of trees. So let's say there's something going on around the suburbs, right? You're not going to see very far away. What I would like people to do is, if they can get themselves within a minute, get inside somebody's house. Now, you might hear the outdoor sirens going on. Then try to seek shelter in someone's house. Go knock on their door, go into a store, anything like that. Get into shelter. If you're out in the plains, or if you're out in a farmland and you see the tornado, which you'll have a better chance to see it coming, drive away from it, right? Don't go toward it. If it's on the side, if you have a good escape route, drive. You can outrun a tornado on a highway. You're not going to do that on 294 in rush hour, but you will be able to do that when you're out in the farmlands. So you can easily drive away from that. Your car's not a good place to be if a tornado's hitting. So if you have a few seconds only, that's when I'd say get in a ditch. I've once thought about getting in a ditch, but for the most part, if I see the tornado and I've got open roads, I'm going to clear out. So that would be my advice. Ditch should be that's your last ditch effort, right?
And how can you tell which direction, like if it looks like it's not, like you said earlier, if you see it's not moving or it looks like it's not moving, how do you know if it's coming toward you or it's going?
That's why, go away from you.
Okay.
If you're going to leave, just go, oh, there it is, run away. Run away from that. Now, you may not have a road, and then that's the problem, right? I don't know if I should go, if it's coming from the side, for instance, you may not know to go north or south, or which direction to go. At that point, try to seek shelter in a building. But usually you get a sense of the tornado coming, drive out of its path. Again, this is all based upon the fact that you have open roads. Traffic lights, people, congestion, not a good thing. That's my biggest fear for the Chicago area. Hunter, you have a great question there. What's your opinion on tornado siren effectiveness? Interesting thing, and I think this is a misunderstanding by a lot of people. Tornado sirens are meant for outdoors. So if you're outdoors, you should be able to hear them. If you're indoors, you should have your cell phone, or you should have NOAA weather radio, something from the Weather Service that sounds an alarm to you. And I think that's really, really important. Okay. The sirens are for people outside. Now, a lot of people in their homes can hear the sirens if they're close. And so you can kind of count on that, but I wouldn't make that as your ideal plan. Now, as far as effectiveness, each community has their say in why they're sounding the sirens. I would prefer it for tornadoes only, or really extreme wind. I mean, that 100, 115 mile per hour, that would be a reasonable time, because that gets people going into shelter. And you'd want people off the highways and that. So that's how I would use tornado sirens. Any other questions? I'm looking forward to the time we can do these presentations with the live audience again. That'll be so great.
Excuse me, sorry, I don't know how to send a message. May I just ask a question if you can hear me?
Absolutely.
Thank you. And it's a long question. And I'm trying to remember exactly what happened. I had a very strange weather event, and I'm really curious what it was. I've been looking for the photograph, and I can only describe it. I was driving on in Michigan on a sort of 4-lane highway, and it was going relatively slowly. And it's really a strange thing. It was a clear day, and all of a sudden we were under this, I don't know if it was a derecho, there was no wind, but there was this extremely weird cloud formation that was, so the sky was white, and all of a sudden there was this gray arc that just came right, really very close to the ground, or right across the road onto the other side, and you were sort of driving through a tunnel. And I kept looking around me thinking, oh my God, am I in the middle of a tornado? I mean, obviously I wasn't, because there was no
Would it be
wind.
something that maybe looks like this?
it was so bizarre. And I'm going to take, sorry, I put a,
If you can see, here's,
yes, it was. And I had to drive under it to
yes,
get to the
okay,
other
so
side. And I'm thinking, oh my God, what's going to come out of the sky? It was bizarre. I've never seen anything like it. There was no wind, but it was really kind of an odd experience. And I was
yes,
really
you
curious.
actually get a cloud like this. So I talked about lines of storms, and I showed you the one picture of maybe what's known as a shelf cloud, because
Uh-huh.
it's a horizontal cloud.
Right.
This one seems to be associated, it's with what we call a wave. It's a gravity wave. So if you ever want to look at it, it's called undulatus, Undulatas, I think. And you get a wave that moves through the atmosphere, and the air is just rising and sinking. And it's rising enough to get the formation of the cloud like this. And then, here, obviously, it isn't going to be mostly clear around it. Phenomenal things, and you'll see them from time to time. But that's probably what it is. Now, sometimes in association with the storm, you might see something like this, where you get this kind of a shelf cloud associated with the storm, which is very similar to what we just saw. It's just that we don't have the thunderstorm associated with it.
It was more like the first one, because there wasn't all this there was no rain, there was no wind, but you just sort of drove underneath it, and it was very odd, and you really sort of wondered what was going to come out of it as you were driving through.
Sometimes, see, this is why I love to look at meteorology and weather. It's just a beautiful example of the power of nature and how many great things you can notice all the time.
Can I share one other quick story, and then because it's just a story. I was down in, I think it was Jamaica many years ago, playing around in some water with a lot of beach expanse, and it was like a foot of water, and I looked up onto the horizon and I saw this rather large wave coming, and nobody else was in the water, and it was far away, but I could tell it was quite large, and I think it must have been like a little tsunami that had thrown up. And I realized something bad was going to happen, and I started to try to get out of the water, and before I knew it, it was over the top of me. And I would say there was probably about, I'm really bad at distances, I probably would say there was about 20 yards of beach. And when I managed to get out of it, because I didn't know if I was upside down, all I knew that I was being flayed by the sand, and I did manage to get up to the top. The whole beach was gone, and I was very lucky that I wasn't near
Where
the
was
resort, because I was going to be thrown into this concrete banister. Probably that would be the end of me, and it was probably, I don't know, but it moved so fast. And
where was this, Jen?
I think it was down in the Caribbean, and I think it was possibly Jamaica, I can't remember. But I would tell you, the only thing that everybody thought rather humorous was I lost the top of my bikini. It was floating away. And I'm like, excuse me, I need a towel. Because, and then it went, but it was absolutely petrifying. And I feel lucky to this day that I wasn't closer to the resort and got thrown into the balcony, but it was very scary. And I came up and I couldn't touch the bottom of the sand at that point. I mean, it was over my head.
It's possible. If it's in the Caribbean, I wouldn't think a tsunami in the more traditional sense, but similar to what happens with the gravity waves we talk about, you can get sudden changes in the wind or pressures that create what they call a meteo tsunami.
Mm-hmm.
Actually, if you ever look up tsunamis and look up the term meteo in front of it, you will find that one of the most significant meteo tsunamis was in the 1950s in Lake Michigan here in Chicago. And a number of people died as the water did that sudden increase and threw people into rocks.
It was definitely not. It was definitely not in Chicago.
But those are the kind of things that are possible. So
yes, and it was absolutely petrifying when it was happening, and I was so lucky that I kind of got out of it.
Well, you
minus my bikini.
Couple other questions. I almost mentioned this about that other question about the underpass. No, you don't want to be in an underpass. It's bad for tornadoes for several reasons. Number one, the wind gets funneled through it. Again, you can outrun it, but the wind funneled through it can be really dangerous. I've seen pictures where a mother and her son were in there, and the mother was found decapitated about a quarter of a mile away as she was thrown. This was the Moore, Oklahoma tornado. It's just really bad news. Now, they're not all bad like that. We've probably seen way back some van that survived in an underpass, but you wouldn't want to do that. The other thing that happens, and I've seen this while out chasing, is that people like protect themselves from hail and they hide under the underpass and then they block the highway. So now there's everybody behind it, can't get anywhere, can't get through. Everyone's a sitting target and it's really bad. So it's really important. Do not use an underpass for this. If you need to get out of your car, find shelter. But if you can't, drive away, get on the other lane and go the other direction. And Hunter, you talked about lightning between clouds. We talk about cloud to ground, but there's a lot what they call CC, cloud to cloud. So the lightning strike is actually all over the place. Let me really quickly, I want to show you something with our satellite page. So I'm going to go over here just for a second. There's the tropical storm. If I look at something like this, I can put in this little, if you take a look over here, do you see all this region? I'm going to go over here so you can see it maybe better. And what's really funny is that all these colors are showing you where there's thunderstorms, that the satellite from way out in space is actually seeing the clouds light up. So not only are they detecting maybe cloud to ground, I can actually see intra-cloud and cloud to cloud lightning. So we see these big thunderstorms moving across Pennsylvania and New Jersey, and that's where all the lightning is. A couple moving across parts of Michigan. Let's see what's going on across Wisconsin. There's a couple of big thunderstorms across northern Wisconsin, another one up here in South Dakota, but nothing down here in our area. But this is some of the things that we use with our satellite page. And you certainly can use that. We can go visible, we can go infrared, see cool things exploding like this. We can actually see this as well. I love this one. This is what we call natural color fire. So if I were to go out west, there were some big fires down here. It looks like they're mostly out. I'm not seeing the mark of this thing at this point. So I'm not seeing the big fires today, but we can actually see where the forest fires are from our satellites as well. So we have a bunch of people using our site who fight fires out in the West. It's kind of exciting. Okay, anything else? Thank you for asking the questions and sharing your stories. That's really awesome.
Yeah, thank you. And I've put a little link in the chat box just now. If you want to copy and paste that into your browser after this and then just give feedback, that would be great. And I'll just leave that up for a second. So if there's any last minute questions that anybody has, go ahead.
Thank you.
And I'll go ahead and stop the recording in just a minute. Actually, I have a question, a last minute question.
Sure.
What's your favorite, do you have like a favorite experience that you've had chasing or anything like that, or just?
Yeah, I think my favorite one, there was a storm across Nebraska, South Dakota, Nebraska, and we got on it coming out of the Black Hills, and we chased this one storm for about 5.5 hours. It became one of the biggest storms I've ever seen, the most fantastic, and the air flowing into the storm, into it, was like 50, 60 miles an hour. It was massive, scary, in the middle of nowhere, and it was an adrenaline rush for 6 straight hours. It was crazy.
That sounds fantastic.
It's a very fun thing to do. Our storm chases are open to anybody who wants to take that class. It's even in district tuition, so nobody has to pay out of district. And we eat well, we have a ton of fun. People come back every year, and it's an experience that's, it could be once in a lifetime or something you just become obsessed and passionate about.
All right. Okay.
It's 10 days long. Yeah.
Yes. All right. Well, I think that's probably it, unless somebody has anything last minute, but thank you so much.
Okay, great. Well, thank you
coming, and
guys.
thank you everybody for coming. I'll go ahead and stop this recording.